Hi folks, how we doing? So what we're going to be doing today? Well, like it says here, we're going to be calculating areas using integration because we're in calculus mode. Calculus. So that's what we're going to be doing here. Right, so we're just going to have a wee question here and see how we go on. So, so calculate area goes with the curves. 4x take away x squared and x. So 4x take away x squared, that's kind of parabolic. So I could show that here. So that's something like that there. And gx equals x, something like that there. Okay. So that's like y equals x and y equals 4x take x squared. So that's kind of saying, that's what they're saying here. And they are saying, can you go and find this area here? So I'll make it a wee bit nicer in a minute. That's what they're saying here. Right. Okay. There's a better picture. Doesn't matter. Like g of x and f of x, just see for our purposes, both of them are equal to y. Okay. Y equals that. What? Y equals that. That's fine. Okay. Right. Right. So the area encodes by the curves. A line's a curve, by the way. Just thought I'd let you know that. So that's the area that we're talking about. That there. That looks yellow to me, but you might have a black and white telly. I know I keep talking about black and white tellies, but that looks like that encodes the area. That's what I'm trying to evaluate here. So how am I going to evaluate that? Well, certain things I need to know here. I need to know about left and right extent of the x values. That's what I'm talking about here. How far are we going from left to right? Okay, so in terms of this, how far are we going left to right? Just so you know. We're talking about this general region here. See that there? Right, okay. See how I'm coming in here? Yep. All the way up and down here, going from left to right. So that's my lowest point there of the area, and coming up all the way to the right hand side. Anything above that, I don't care about, because that there is the furthest point to the right. So hopefully you can see that that's what we're talking about here. So we are talking about the extreme left hand side, here, And it looks like from the graph that's 0, and looks like we're looking at the extreme right hand side there. So it looks like it's a kind of x value down there. So we're going to go and find that. So there's two x values that we want to find. Right, okay. And these are often referred to as the limits of integration, or summation, or summing up, adding up, whatever you want to call it. That's what we're doing here. We're summing things up. We're going to sum up that area. Okay. So in order to get these points, what we're calling the limits, okay, we need to find these. We need to find that and that. And this is where g of x is actually equal to f of x, because that line meets the curve there. So that's exactly what we're going to do. Let the line equal the curve, f equals g. Okay, so let's start taking things over. So for x take away x squared equals x, get everything over to the one side, whatever, make it equal to 0. Hopefully your algebraic knowledge is sufficient that it can get you to there. Okay, you've got a quadratic equation here. Let's factorise it and solve. So taking out a factor of x, so we've got x squared take away 3 take away x in the bracket equals 0. That's only possible mathematically if x equals 0 or the contents of the brackets 3 take away x is equal to 0. So that's what we've done there. And x equals 0, 3 take away x equals 0. So what does that mean? That means x equals 3. Okay, that's how to get our limits of integration. Okay, we're looking at the area between x equals 0 and x equals 3. And so they're referring to these here are our left or right bounds. Okay. So we're going back to the formula there. Area, what's this? Area equals top minus bottom. But we're talking about the boundaries here. Top minus bottom. The boundaries of the curve. So what is top and what is bottom? Well, we're talking about in terms of a horizontal nature. So top. So what we're aiming at the kind of central region of the curve here. So what is the top bound and what is the lower bound? Well, the top bound seems to, well, is that apparent? Like I said, I'm coming down in a horizontal fashion. I might put in a wee line here, just so you can get that idea there. So, um, as I'm coming down from the top here, what did I hit first? Yep, I hit that there. Top, 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 right to there. I'm coming down to there. So that there is the upper bound of the region. That's what I'm hitting there. Right. And I'm now saying, oh, that there is the lower curve. So why is that the lower curve? So again, if I put in a horizontal line, just move it over here. So I moved through top, 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 top. I got to there. I got to my right limit. So this g of x line, I'm crossing it. That looks like the bottom boundary. of my region. So that's where that is coming from. Right, so hopefully top and bottom is clear. But you need to be aware of which one in what order. So which order? So top is the curvy one. That's actually that one there. Okay. And the other one is actually that one there. So you need to make sure that these are in the right order. Okay? Need to make sure of that. Right. I think. Can we move on from there? So top minus bottom. Right. So we already had the limits of integration. We got 0 and 3 because we actually saw that there, that there. That wasn't very good. With that there, that there. That was 0 and that was 3. That's where these values are coming from, and we're trying to work out that area there. So that's where the 0 and 3 are coming from. We can only work out with integrations is the area between the x values, okay, from 0 to 3 here. That's what we're doing. Right, let's move on. Top minus bottom, so 0 to 3, top minus 1. What was the top curve, top boundary? 4x take away x. So I just want to emphasize here, but people always ask, why is there a minus in there? Oh, you can go and debate that for yourself. It's always a minus in there. Always, always, always. We're subtracting one error from another technically. So we've always got a minus in there. Right, next, top curve, bottom curve. A line's a curve, okay. Tied it up. How did I get 3x take away x squared there? No, 3x take away x, because there was 4x in there, and I was taking away x, and that gave me my 3x, and then the negative x squared, that just came from that part there. So that's how I got that there. Okay. So that's me got that there. And this is actually the only part we're going to have to integrate. So 3x take away x squared, that's actually called the integrand. I'm going to, so 3x to the 1. So I'll go from 3x up to 2, divide by 2, and the x to the 2 goes to x to the 3 over 3, and I got a wee minus between them. Right, so that's what I've got there. That's me integrated it. Okay, so I know the limits, so I'll just shift the limits over here. 3 and 0. It doesn't matter how you write this down. Some people just write it as 3x squared take away x cubed over 3, and sometimes I put a line down here and write it as 3, 0. It doesn't matter. Just depends on what kind of textbook you're looking at here. That's fine. So we'll just move on. So what we're going to do, we're going to cut and paste. So what I've done here is I've cut and pasted. What I mean by cutting and pasting is, see that thing there? I've taken that there and I've copied it there, and the only thing that I've removed is the value of x. So I've removed that because I know the value of x I'm going to use here. I've got two of them. So that means I have to have another one, the exact same thing, but then I need to subtract between them because I'm taking one area away from another. So what's going to happen next is I'm going to take my upper limit of 3, that's going to get in there, and it's going to get in there, and the lower value, which is 0, is going to get in there, and going to get in there. I'm not happy with that. My arrows were all over the place there. 3, in there, bang. In there, bang. 0, in there, bang. In there, bang. So the values are going to get in there. Okay, that's better for me. Hopefully that's better for you. Right, okay. Let's put the numbers in. Okay, I've just bracketed it all up. Big rectangular brackets for safety. Okay. Right. Upper limits, lower limits. Let's start working things out here, folks. I think I'm going to move this one to another page. Yep. And just so you can see here, 3 times 3 squared is 27 over 2. Leave it. 3 cubed is 27 over 3. Leave it. 3 times 0 squared is 0. 3 times 0 squared is over 2 is 0. 0 cubed over 3 is 0. We'll leave that. Okay. I've done that there. The right hand bracket is going to come out as 0. I've just put it in. 27 over 6 take 0. 27 over 6, that's fine. I'm okay with that. Or 4.5 as a decimal, but it's a fraction. That would be 9.2. And I think I'm happy with that. We just want to go. That page is just flipped down from there. So that's kind of showing you the basic format of how we actually evaluate the things. So get an area here. Whatever the functions are, f and g, or h and k, or y and z, d and e, whatever they are. Just remember the central area that you're actually looking for. That's the area you're looking for. Okay, area you're looking for. Fine. What you need to do is here is look at the extreme values of x. Okay, so we'll call that maybe x equals a and x equals b. That's fine. So that's the left and right extent of the area we're looking for. And then it's the top minus bottom. And that's a function we're referring to as f and g. Right, so I think I'm going to leave it there. In fact, I am indeed going to leave it there. So I hope you're fine with that, folks. Right, so let's go for that. Let's leave it like that.